So in this video I will try to illustrate MPLS and MPLS with VYOS. And why use MPLS compared to traditional routing? Let's just say that you have this setup that I have here. Let's see if I can maximize this. Got 4 routers with VYOS 1.5 that supports MPLS. And what benefit does MPLS bring to me? So imagine this, that you got in this setup, right? You have R1, 2, 3, 4 connected back to back. E0, E0, E1, E1, E0, E0. And this network is 12.0.0x/24.1.2. This network is 23.0.0.x.2.3. This network is 34 or 24. I actually did that. .x.3.4. I'm actually going to change this to 34. All right. So if you have, I've got this set up now. Let's just say that this is your West Coast core router. West Coast core router. And this is your East Coast core router. And obviously MPLS is beneficial for very large networks. So this East Coast core router is getting thousands of stub networks. Stub networks essentially is like users, applications, what have you. Meaning there is no transit, there's nothing beyond them, right? So they're stub networks, thousands of them. And I need to get the routing done between East Coast core router to West Coast core router. The traditional routing or traditional method is what? Traditional way is routing, where you flood all of these thousands of networks, stub networks, into your core. So this is your core essentially. And then if there is something going wrong with the user network, cable loose, network outages, blah, 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 you got, dozen data centers or servers here, hundreds of servers and applications here. In a large network, something is always going wrong. Circuits, users, switch failures, what have you. You will be flooding this thousands of networks into your core, and they'll be always unstable, right? So to fix that, obviously there's a solution called summarization, which is not very trivial. You have to, it's a lot of work, especially with a lot of the prefixes. Summarization is not very straightforward thing to do. So you summarize this way. The other way is to make sure that these core routers do not get flooded with all these prefixes, and you have a better way or better core stabilization is obviously to do, instead of flooding all these into your network, you advertise this. The other way obviously is the MPLS way. And you don't flood anything. So the traditional routing requires, when a packet comes to router 2, it needs a destination address. And if it needs to go to this guy, it needs that routing table, that information. But in MPLS, you do not have these flooded. That's what we're going to see. We're going to see the traditional way. And then when we're going to convert this traditional routing into MPLS. Multi-protocol label switching, right? So obviously for that, you need, in the core, you'll obviously have an IGP, and we're going to be using OSPF for whether you want a traditional or MPLS. OSPF is going to be used in core anyway. But to advertise these stub networks between West Coast to East Coast without the core having the knowledge or getting flooded, you would need BGP, IBGP, because this is going to be put in the same AS. And what's going to happen is we're going to create BGP peering and advertise these routes via BGP from both sides. So the core will have no information on these stub networks. So we'll create dummy interfaces, dummy 0, dummy 1, and advertise these in BGP. Same here, dummy 0, dummy 1, and advertise them in BGP. Okay. But first we'll do the traditional routing through OSPF, advertise these routes, or one route just to make it simple, and see how traditional routing works, and then we'll convert this into MPLS and see what MPLS requires. Obviously, for it to work, it requires BGP, and it also requires LDP, which is Label Distribution Protocol. So it requires MPLS to switch and LDP to distribute the labels that are binded with these prefixes. So let's take a look. So here's your network, R1, R2, R3. Here's my routers, the core routers that are at the bottom, and the PE routers or the edge routers are at the top. So I have IP connectivity. I'm going to convert this into 34. Delete interface E0 address. Set interface E0 address 34. Delete interface E0 address. Set interface Ethernet E0 address 34. Commit. Run ping 34 3. Yep. So your transit networks are all up. I can ping my neighbors 12001, which is this guy. I can ping 24 23 3, which is this guy. So all good, right? Now let's get OSPF going. Start with router 1, set protocol OSPF, area 0, network is 12. That's all you need. And let's just create the dummy interface to see how traditional routing is going to work. Set interface dummy. Dummy 0 address. Let's call this 10.111/32. And then advertise it in OSPF. Let's enable OSPF here. Network is 12. And the other network on towards R3 is 23. And we don't have any dummy interfaces. Set protocol OSPF, area 0, network 23. And we have network 34. And on the coast, set protocol OSPF, area 0, network 34. And my dummy interface. Set interface, dummy 0, address 10.44/32. And put that in OSPF. So now I should see this route in my other host. Not yet. Not yet. Not yet. Not yet. Unreachable. Show IP OSPF neighbors. Got no neighbors coming in. Run ping. Is pinging. Show protocol OSPF. What did we miss? We got 24. I got 10. Did I miss anything here? Show protocol OSPF. 12.23. Run show IP OSPF neighbors. OSPF is not enabled. Maybe I forgot the commit. Okay, neighbors coming up. Neighbors coming up. So now as soon as the neighbors come up, I would see the route, and here it is. So now I can reach my West Coast. Right? But at the cost of having these routes in my core. So the core routers have all these stub routes. So how do I get rid of these stub routes in my core routers 2 and 3 and yet be able to ping or connect to my coast to coast? Okay. So far what we did is this. We enabled OSPF here. From here to here, and we advertise our stub, dummy stub interfaces into OSPF. And the routing, traditional routing worked. Now we're going to convert this traditional routing into MPLS. To do that, we will require to convert our router 1 to a PE, this guy into a P, this is a P, and this is a P, and this is a PE. Provider edge, this is MPLS terminology, provider edge and provider networks. How do I do that? For that to happen, we will have to put our loopbacks here. Loopback, 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 loopback. We create loopbacks and we address them, and then we put these into OSPF. And we will disable OSPF advertisement. So we're going to disable our dummy 0, which was 10/32 here, and dummy 0, 10/32 here. I'm going to take these out of OSPF. And we're going to put them or advertise them into BGP. Before we can do that, we need to create the loopbacks so that we can create a BGP peering between the loopbacks. So the BGP peering is going to look like this. That's your BGP pairing, and it's going to pair between loopback 0 here and loopback 0 here, and his address is going to be 4. And we're going to advertise these loopbacks into OSPF. So OSPF will have loopbacks and this transit loopbacks. This is going to be 222. It's going to be 333. It's going to be 444. And this is all going to be in OSPF. And this is also going to be used for BGP peering. So it's orange and blue. These are not going to be used in BGP, just OSPF. Okay. Maybe I should rewrite this. And we're taking off 10.11 from OSPF and putting it in BGP. So just to make sure it gets more readable and clear, this dummy interface is going to get BGP. In BGP, same here, this one is going to get BGP. So now you've got BGP to BGP going between router 1 and router 4, and 2 and 3 would have no traditional routing information for them, right? So we're going to do this. All right. Now, let's go back to our setup to set up BGP, take out OSPF for the dummy interfaces, and enable MPLS and LDP. A lot of work. So now we do show protocol OSPF. We edit protocol OSPF. We delete network area 0, network 10. So now it's going to disappear. Do the same here. Edit protocol OSPF. Show, delete area 0, network 10, 4. Commit. And now the networks, these networks are going to go disappear because they are no longer available in OSPF. All right, so they're gone. We still need connectivity, so let's see how we get it. Let's get our loopbacks up. Set interface loopback. Address is going to be 111/32. Set protocol and put them in OSPF. Set protocol OSPF. Area 0. Network. So now, instead of the stubs, we just need loopbacks. Set interface loopback, address 222/32. Set protocol OSPF, area 0, network. Set interface loopback, address 3333. Set protocol OSPF, area 0, network. Set interface loopback, address. Set protocol OSPF, network. So we should now see all the loopbacks. One, two, three, four. Good. So we should have reachability 2, 4 with source address 1. Redo. So now our core routing table is going to look like this. Just the loopbacks and the transits and the loopbacks. That is how our core should be. No stub required. No stub networks. Okay? But now we lost connectivity to our host. Because this guy has no information. Nor does this guy. Okay, let's use MPLS. For requirement for MPLS, we got the loopbacks up, we put it in OSPF. Now we enable MPLS and LDP. Here are the steps. Set protocol, MPLS, LDP, interface. So let me bring up the diagram. So we're going to enable MPLS LDP here. Let's change our color now. Our color would be, let's say, red. LDP between these. LDP would be between transit. and MPLS would also be on the transit interfaces. All right. And this is specific to VYOS. I think Cisco requires LDP and MPLS on the loopbacks as well. So now let's get the MPLS LDP enabled. Set protocol MPLS LDP interface Ethernet 0. That's all that this one wants. And then LDP requires discovery transport on IPv4 address. I'm going to use the loopback and the router ID. Should not complain. Let's do the same here. Set protocol MPLS LDP router ID 2222. Discovery transport IPv4 address 2222. That's your loopbacks. You're basically using OSPF to transport. And what else was there? MPLS interface, LDP interface. Interface in this case is going to be Ethernet 0 and Ethernet 1. Let's see if the neighbors come up. Run show MPLS LDP neighbors. Operational. All right. So let's do this here too. Set protocol MPLS LDP. Discovery transport v4 addresses. This case would be 333. Router ID is going to be 333. And interface would be both Ethernet 0, Ethernet 1. Should bring up my neighbor. Run show MPLS LDP neighbor. 222 is operational. So now I have two of these here, 1 and 3. And once I bring this guy up, we should be set from MPLS perspective. Set protocol, MPLS, LDP, router ID 4444, transport discovery transport IPv4 address 4444, interface, I think it's E0. So now I should have two here, and one on each. So we're good. MPLS is up. Let's see what the MPLS table shows us. It shows us transit networks and their labels. This could be difficult to read and understand and figure out the logic, but it'll get you going to see how the transit networks. You want to see the binding, you so go do LDP binding, and it'll tell you here, I've got for one, I am assigning 16, but I'm learning implicit null from the remote, which is obviously implicit nulls. I don't need a label to go to 111 because it's a direct connect. And that's why it's in use. Other routes are only going to come into use when this one fails. It's 333, which is this guy, implicit null again. I don't need a label from remote side because it's directly connected, and my local label is 17. I'm assigning 17. I'm learning implicit null. That's why I'm going to be using this. And 444, where's 444? Here it is. Look at the next top is 1 and 3, right? So it's 1 and 3, and that's going to be recursive on a transit. 444 is like this. To reach 444, I'm using local label 18. I'm assigning 18, but the remote label is 16. So if I want to go to 444, I'm going to assign a label 16 going towards 333, and 333 is going to say 444. It's an implicit null because it's directly connected. See, this one he's assigning 16 and he's learning 16. So that's how your MPLS labels gets assigned, and you're good to go. Now we need to make sure that you have reachability to your loopbacks coming from your, and you don't. So let's see what's going on. You got 4, right? There's something not correctly configured on the MPLS site. So this should work. And if it's not working, that means there's something not correct. Show protocol MPLS. You got LDP, interface. So I need to put, and then you got show protocol MPLS, 2 interfaces. Show protocol MPLS, 2 interfaces. Show protocol MPLS, 1 interface. So I think I'm missing some interfaces here. So I think we need to add these interfaces as MPLS as well. It's just one of those things that each different distribution or implementation of MPLS required from a configuration standpoint, right? So set protocol MPLS interface, you gotta put that in LDP as well. So we got it in LDP. Gotta do this in MPLS as well. So do the same across the board. We missed that. Ethernet 0, Ethernet 1. Set protocol MPLS interface. Ethernet 0, Ethernet 1. Set protocol MPLS interface Ethernet 0. We should be able to ping. And we're still not able to ping. Let's double check. Show protocol MPLS. Got Ethernet 0 connected to Ethernet 0. Show MPLS. Ethernet 0, Ethernet 1, Ethernet 0, Ethernet 1, transport 2, router ID 2, router ID 111, transport 111, discovery. What are we missing? Show protocol MPLS, Ethernet 01, LDP 0133. Show protocol MPLS 0, 0, 4, 4, 3, 3, 2, 2, 1, 1. Is this the correct interface? Let's see. Double check our E0, E1, E0, E1, E0, E1. let's check the neighbors. Show MPLS LDP. LDP neighbors. And operational. Run show IP route. I've got 1, 2, 3, and 4. Run ping 4. Run ping 4. This one should work because it's an implicit null. But it's not going the other way. Run ping show IP route. Got 1, 2, 3, 4 /32s. Phone rings. So after configuring the interfaces and rebooting the 1.5, which is obviously sort of a bug, but it does work, and it's a rolling release, VYOS 1.5. We got this thing to ping, so show IP route. We got 444 and MPLS enabled, so it is now after the reboot pinging from west to east, okay, and from east to west. So it's working end to end, and here's the end configuration. I just added the loopbacks as well in the protocol MPLS and LDP. So here's your show configuration on the core routers. And here's the configuration on the east-west router. So now we've got this MPLS enabled. So let's bring back our whiteboard. And so we've got the LDP going with loopbacks put into LDP and MPLS, OSPF enabled, routes come in, everything looking good, right? So, but we need to get our dummy interfaces enabled and pinged. So, show IP route on the east and west coast has connected 10.1, has no 10.4.4, has connected 10.4. Now we're going to use BGP to advertise these because we don't want to use OSPF because OSPF would populate it here as we saw in the traditional routing. That if we put this stub networks in OSPF, it'll get populated in the core routers. So there's no 10 here. Let's get BGP going. Set protocol BGP. System AS is 123. Whatever you want to make it up. Let's just make it a simple one. And then we do neighbor is West Coast. Remote AS is same, so it's an IBGP, and then we bring it up as address family, IPv4, unicast, and then we advertise it, advertise our network, and address family, what is it, IPv4, unicast, and the network that we want to advertise is 10.1.1 network. So that's your BGP there. Let's do BGP on the west coast or east coast. Neighbor is our west coast. And we'll put him in address family IPv4 unicast. And we'll advertise the network and IPv4 unicast, and the network here is 10.4.4. So this should bring our BGP up. It's inactive, it should become app. Okay, it's not up because we missed one command. And that command is that our network, our neighbor 4's update source is loopback. Do the same on the west, east. And now it should come up. And it's up. And it's learned a prefix as well. So now we do run show IP route. Should get a 10.4. There it is. We get a 10.4 through BGP. Recursive 12.0, and this route is not present in the core. No 10.4, no 10.1. We've got 10.1 on the East Coast. We've got 10.4 on the West Coast. So we got stub networks going. Let's see if I can ping them. Source 10.1.1.1. Yep. So there you go. Your network is now enabled with MPLS without the core routers knowing about these stub networks. See that? So that is, we go through the configuration one more time, show protocols. Now that we got BGP, so we got BGP, we got MPLS. See if I can. And OSPF. Show protocols. You got MPLS and OSPF only, no BGP in the core. MPLS and OSPF, no BGP in the core. You got BGP on the edge only. BGP and MPLS. So this is how this is one of the use cases, obviously MPLS. So all of this is happening in your core, what you got a global routing table. So your dummy interface gets advertised through BGP, learns, and it's using labels to switch the packet without core routers to have learned the stub networks, right? So that's your MPLS use case, one use case that we just did traditional routing to MPLS LDP and BGP on the edge. So that is your one use case. Obviously, MPLS does get used in VPNs as well. And that's VPN primarily means that now you have all these customers. If you're a service provider, you have customer 1, customer 2. You need to advertise them on the other side, customer 1, customer 2. Then you need to put it in VRF, same VRF here, same VRF here, and then go into the BGP address family, advertise those routes, right? A lot of configuration there. I do have a video on that using VYOS for MPLS VPN. But in this one, I'm not gonna go and do in the VPN part. It gets pretty complex, and I just wanted to illustrate how MPLS without the VPN part could be used just to do from traditional routing to MPLS by having your core router free of the stub. No stubs, right? No stub routes in your core. No stubs. It's using labels to do the switching. Now, if you look at the label table, you do see, so let's go take a look at the labels. Show MPLS table will just give you the labels for direct connect. Binding will give you this guy. So you do have the labels, otherwise you would not be able to put and assign a label to it. So you have a label going towards one West Coast, but you have label for 10.1.1 and 10.4.4. Show MPLS LDP binding 10.4.4 towards your implicit null, towards your edge routers, but it does not have anything from a 10.1 perspective or 10.4 perspective on the core routers. This one is obviously coming because its next hop is 1.1.1. Learning that label. So that gives you some fun time to play with MPLS. And again, once you configure this on VYOS 1.5, you would save it and reboot the routers to make it work. That has happened to me several times, so that at least gets you going to play with it. What else can I cover here? I think that's about it. Hope this helps.